In this question, what we need to find is the area of the non-shaded part. So the white part in the center, we need to find that area, and we also need to find the area of the entire circle, and we need to find the area of the white part as a percentage of the area of the entire circle. So that's what the question is asking. So now what we can do is, as you know, we do with these questions, we start with marking the center. So if I just mark the center, so this is the center of the large circle, and if I call it O, and then if I try to draw a line which is a diameter passing through these centers, then the center of the small circles, so if I say that's X and Y, the center of the small circle, and this circle I can call the center as B, or I can call it as Z. Goes more at X, Y, Z. So if I join them, and so then you see, I need to find, if I say the radius is R, the small circles have a radius of R. If I also name this point here, as, suppose I were to call it N, and if I call this point as M, so MNY would be R and XM would be R, right? So now that's the small circle. The larger circle, if I were to call it, say, AB, so the radius of the large circle is R. So if I say radius of large circle is R, small circle radius is smaller, right? So how do we find the area? So we find the area of the unshaded part. It's not hard. What we need to do is a couple of steps. I mean, more than 2 steps, but what we need, if we join ZO, okay, so then you see, because triangle ZXY is isosceles, and this would be the perpendicular, so I can write triangle ZXY is isosceles, and ZO is perpendicular to XY, and XO is equal to ZO, right? So now we know that AO is R, capital R, the radius of the large circle. So XO would be capital R minus small r, because this bit is R as well, isn't it? So it will be capital R minus small r, and that is equal to ZO. So what is the plan to find the area? The plan to find the area is to find the area of this arc. So if I use some highlighter color, and if I say the plan is, so some thin one, the plan is to find the area of this arc, and this arc, they are the same. Oh, sorry, not arc, the sector, my mistake, sorry, apologies. The sector So we need to find the area of these two sectors, and then we subtract it from the area of the triangle XZO, and that should give you the area of this white part. And you see that there are 4 of these white parts here. 1, 2, and if I were to extend this line, so then that would be 3 and 4. So there are 4 parts here. So we need to multiply it by 4, the area of this tiny white bit, and I find it. So that shouldn't be very hard. The reason it's not very hard is you already know that this is isosceles right angle triangle, and this is 45 degrees, and this angle is 45 degrees. So then area of the sector is some other color. Area of the sector, so I have Z. If I say M and N, so this is N. So area of the sector MZN would be pi r square times theta, which is 45 out of 360 degree. So that would be, this is 1 out of 8, and so it's pi r square out of 8. So we have the area of the sector, and so the area of the triangle XOZ would be half times base times height. So half times capital R minus small r times r minus r. So that is half times r minus r whole square. So our area of the non-shaded part would be equal to area of the triangle, that's half times r minus r whole square, and minus pi r square out of 8. But we need to multiply it with 2 because there are 2 of these shaded, 2 of these segments, not arcs as I was saying, arc is a line. There's a segment, I don't know why I keep saying these. Sorry about that. So pi r square out of 8 times 2. So then what we can do is, this has to be multiplied by 4 because there are 4 of these white parts, so that we would get 4 times no, but there, before that, before simplifying it, I need to have a relationship between this capital R and the small r. Okay, so we can do that. What I can do is, so I can take all of it off. Right, so what I can do is that if you look at the triangle, in triangle XOZ, what we have is using Pythagoras theorem. So so if you can't follow my words, you can follow the writing, or follow the video in terms of what I have written. That's why I try to write it down, and I think you can understand, but my voice may not be correct, be that loud, sorry. So using Pythagoras theorem, what we have is r minus r square plus 2r square. So you'd have 2 times r minus r square is 4r square, and that's 2, so r minus r would be square root of 2r. So we can say capital R is 1 plus root 2 times small r. So this value of capital R we will be using in the other one. So we got capital R is 1 plus root 2 times small r. So we will say 1 plus root 2 times small r. So if we use that here, so I would get 4 times half 1 plus, instead of 1 I can write r plus root 2r, r plus root 2r minus r whole square plus 4 pi r square out of 4. And see, the r's get cancelled out, and I am left with 4 half, within brackets I have the 2r square, so I will write times 2r square and plus pi r square out of 4. So these two gets cancelled, so I am left with 4r square plus pi r square, the 4's get cancelled. So that is, if you take r square outside the bracket, it is going to be 4 plus pi. So that is the area of the unshaded part. Okay, so I'm going to write it down here. I will erase this and I will write area of the unshaded part is equal to, what did I get, r square multiplied by 4 plus pi. Now area of the large circle that would be equal to pi capital R square. So again, instead of capital R, I need to write this 1 plus root 2 times R. So I'm going to write this. So R is 1 plus root 2 times small r times R times 1 plus root 2 square, that is pi r square 1 plus root 2 square. We keep it like that because we need to find the percentage. So the percentage not shaded, percentage of area, a percentage of the figure not shaded is equal to, we have to do this bit, r square 4 plus pi divided by pi r square times 1 plus root 2 square. So because we have to express it as a percentage here with this unfriendly looking number, or it's irrational number, so we have to use the calculator and we can take the r square off, so we can get 4 plus pi, which is quite neat, but we have to use find the percentage, and we have to multiply it by 100, sorry, and then 1 plus root 2 square and multiply it by 100. And then after using my calculator, let me check. There's a mistake here. So it is minus, say I made a mistake, it should be minus, so it's minus and minus, and then so it's minus again, and it's minus. It's minus, so it's 4 minus by, right? So if you do that, so did I get the right answer? Yes, it is right. So far it is right, and the r squares are cancelled. Yes, so that is the right answer. And if you now use a calculator, so without, let me check one more time to make sure I'm not made any mistakes. So yes, I don't think I made a mistake. Unless you happen to spot any, you can let me know in the comments, but I don't think there are any mistakes. And if you are to simplify this, you will get 4.7%, and that is the answer. And so thank you so much for your patience, and thank you for viewing.